When comparing and ordering real numbers, the easiest strategy is to convert one or both of the numbers into decimals, and then add any placeholding zeros you need in order to make an accurate comparison. In this example, we've got 1.7 and 1 7/9. 1.7 is already in decimal form, so we'll convert 1 7/9 to decimal form as well. While it's important to be able to convert this fraction into a decimal by hand, for the most part, we'll be relying on the calculator. 1 7/9 is equivalent to 1.7 repeating. But which is larger, 1.7 or 1.7 repeating? This is where the placeholding zeros come in handy. We add zeros to the 1.7 until both numbers are the same length. But the only part that matters for determining which of the two numbers is larger is the first place the decimals differ. So ask yourself, which would you rather have? $1.77 or $1.70? The larger of the two numbers should be clear. Write the original two numbers on a horizontal line and indicate the larger value with our less than greater than sign. The statement can be read forwards or backwards. 1.7 is less than 1 7/9, or 1 7/9 is greater than 1.7. Let's do another example. Which is larger, the square root of 12 or 3.46? We'll use a calculator to determine that the square root of 12 is approximately equal to 3.46410165. That's more decimal places than we need, but if we stopped just at the 6, we wouldn't know which of the two numbers is larger. It's this 4 right here that will make the difference. If we write down 3.46 and add a placeholding 0, it should become clear that the square root of 12 is slightly larger. 3,464 is a bigger number than 3,460. That statement is true no matter where you place the decimal. So we write the two numbers down horizontally and indicate the larger number using the less than greater than sign. Again, this statement can be read forwards and backwards. Square root of 12 is greater than 3.46, or 3.46 is less than the square root of 12. Both statements are true. In this example, the two numbers are equal because the square root of 64 is equivalent to 8. This statement is also reversible. 8 is equal to the square root of 64. Comparing negative numbers can feel a little backwards. Negative 7/8 is exactly negative 0.875. We add the placeholding 0 to negative 0.87 to get negative 0.870. At first glance, 875 is larger than 870. But we're dealing with negative numbers right now, which means the opposite is true. Think about it this way. Would you rather owe somebody $875, or would you rather owe them only $870? If you only owe $870, you have less debt to pay. Therefore, negative 870 is a larger number than negative 875. We express the relative value of the numbers just as before. Negative 87/100 is larger than negative 7/8. Here's another example with negative numbers. Negative 1/2 is mental math when converted to decimal, and negative root 2 can be easily found with a calculator. Just be sure that you placed a negative outside of the square root sign to find the approximate value of negative 1.41. In this case, it can be helpful to write a placeholding 0 both in front of the decimal and behind the 5. And while most of us would rather have $1.41 than 50 cents, you're always better off owing less money. So while 141 is bigger than 50, since we're in negative land, what we expect to be true is reversed. So negative 1/2 is greater than negative square roots of 2.